In this video, we'll identify the key math skills you'll need for this chemistry course. Those include place values, positive and negative numbers, percentages, solving equations, and interpreting graphs. We'll begin by identifying place values. For example, let's start with the number 2518. What does this number mean? Well, we could break this number down into its parts. We could express this number as 2,000 plus 500 plus 10 plus 8. These will help us understand the place values. The 2, let's circle things in red. The 2 is in the thousands place because we have 2,000 things in this number. Next, we have the 5, which is in the hundreds place. There are 500 things expressed in this number. Plus, the 1 is in the tens place because there are 10 things expressed in this number. And 8 is in the ones place because there are 8 things expressed in this number. When we add all of those place value digits together, we get 2,518, the total number expressed here. Those are our place values. Let's look at place values for a decimal number. Our units for these numbers are grams. So let's look at the place value for this decimal number, 6.407 grams. We have a 6 in the ones place, just like we had an 8 in the ones place for our previous number. There's nothing in the tens place or the hundreds place or the thousands place here. We just have 6 ones, but we have something smaller than 1. We have these decimal numbers that express a fraction of 1 gram. Okay, so we have the 4 in the tenths place. That means we have 4/10 of a gram. We have nothing in the hundredths place, but we express that as a 0. Notice that this is an important placeholder. We can't leave it out because if we did, then our 7 would be in the wrong spot. We have to have that number here, and it is significant. We'll talk about that later on. But we need that hundredths there, that 0, as a digit, as a placeholder for our hundredths place. Next, we have 7 in the thousandths place because we have 7 thousandths of a gram. That's part of a gram. So we would need 1,000 of those parts to make up a whole gram. We could add these digits together in the same way we did previously. We have 6 ones, so 6 grams, plus we can add 0.44 of a gram. So we would need 10 of those to make a whole gram. Plus we could add 00 for our hundredths of a gram. We need both zeros to make up the placeholders here, okay? And we need 007 to express our thousandths of a gram. When we add these all together, we'll get our total number. Okay, so these are the place values for a decimal number. Let's have a learning check. What is the place value for the underlined digit in 35.679? That's right, the 7 is in the hundredths place. Now let's explore how to use positive and negative numbers in calculations. A positive number is any number that's greater than 0 and has a positive sign. We often leave the positive sign off because it's understood to be there in front of any number that doesn't include it. A negative number is any number that's less than 0 and is preceded by a negative sign. You should be familiar with the rules of positive and negative numbers, but we'll go ahead and review the multiplication and division rules right now. When two positive numbers or two negative numbers are multiplied or divided, the answer is positive. The sign plus is understood if it's not included. For example, positive 2 times positive 3 is positive 6. When you have two negative numbers multiplied together, it ends up being positive for the answer. Negative 2 times negative 3 is positive 6. The same is true for division. 6 divided by 3 is 2. Both of these numbers are positive, and the plus sign is understood to be there. Negative 6 divided by negative 3 is positive 2. When a positive number and a negative number are multiplied or divided, the answer is negative. 2 times negative 3 is negative 6. Negative 2 times positive 3 is negative 6. 6 divided by negative 3 is negative 2. And negative 6 divided by negative 3 is negative 2. Next, we'll review the rules for the addition and subtraction of positive and negative numbers. When two positive numbers are added, the sign of the answer is positive. When two negative numbers are added, the sign of the answer is negative. When a positive number and a negative number are added, the smaller number is subtracted from the larger number, and the result has the same sign as the larger number. Let's look at some examples. 3 plus 4 is equal to 7. They're both positive, and the answer is positive. Negative 3 plus negative 4 is equal to negative 7. They're both negative, and the answer is negative. 12 plus negative 15 is negative 3. We subtract 12 from 15 because the absolute value of 15 is larger. The magnitude of 15 is larger, and since the 15 was negative, the answer carries a negative sign. When two numbers are subtracted, change the sign of the number to be subtracted, and then follow the rules for addition. 12 minus positive 5 can be rewritten as 12 minus 5, and that's equal to 7. 12 minus negative 5 can be rewritten as 12 plus 5 because 2 negative makes a positive. And the answer then is 17. Negative 12 minus negative 5 can be rewritten as negative 12 plus 5. So, since 12 has the larger magnitude, the answer will be 7 because 12 minus 5 is 7, as we discussed in the previous slide. And the answer will carry the sign of the number with the larger magnitude. 12 minus positive 5 can be rewritten as negative 12 minus 5, which is negative 17. Every calculator is different, and you can review the basic operations of your calculator uh, from different YouTube videos or from your calculator manual. If you need help using your calculator, you can ask your instructor for help. Here are some basic calculator operations that work with most calculators. Here we have example 1. 15 minus 8 plus 2 equals what? So here's how we put it in. 15, and then we hit the negative sign, and then the 8, then plus, then 2, then equals, and our answer is 9. For the next example, we have 4 plus negative 10 minus 5 equals what? We enter 4, then the plus sign, then 10, then the plus or minus to change the sign, okay? Because we want to change the sign on the 10, and then we hit minus the minus button, and then 5, and then equals 11. You could also just put this in as 4, okay, and then hit the minus button, and then 10 if you understand that you need a negative 10 here, and then the minus button, and then 5, and that should be equal to negative 11. Next, we'll review the operators for multiplication and division. 2 times negative 3 equals. You'll enter the 2, then the times button, then the 3, then the plus minus button, which changes the sign on the 3 to negative, then equals, and we get negative 6. Next, we have 8 times 3 divided by 4. It doesn't really matter the order of these operations. We enter 8, times button, then 3, then the divided button, then the 4, then the equals button, and we get 6. Next, we'll discuss calculating percentages. Calculating percentages is an important concept for any chemistry course, and in fact, many math courses and many of your science or business courses will include calculating percentages. You should probably learn to calculate percentages just for your daily life. For example, if you have a 20% off sale, you may want to understand how much that 20% will be and what percentage will be left. The general formula for percentage is part over whole times 100. Okay, and this is the general formula for percentage. You should probably memorize it. Let's look at an example here. To determine a percentage, divide the parts by the total whole and multiply times 100. We have, for example, 8 chemistry books out of a total 32 books in our bookshelf. We want to know what percentage of our books are chemistry books. So we put 8 in the numerator and 32 in the denominator. 8 divided by 32 times 100 gives us 25%. 25% of our books are chemistry books. We can also express the number of, let's say, red balls out of total balls. 5 red balls divided by 100 balls total gives us, times 100 gives us 5% red balls out of our total balls. To get a decimal back out of a percent, you can simply divide your percentage by 100 to get the decimal value. Next, we'll discuss solving equations. Equations can be rearranged to solve for an unknown variable. Generally, that's what we're going to want to do in chemistry. Let's take, for example, the equation 2x plus 8 equals 14. We need to solve for x. X is what we don't know. How do we solve for x? Well, remember, anything we do to one side, we have to also do to the other side to keep our equation equal. That's the general idea for an equation. For the equation 2x plus 8 equals 14, we need to get the x on a side by itself. We'll need to use a couple of different mathematical operations in order to do this. Let's begin by getting the 8 from the left side to the right side. So 2x plus 8, what can we do to get the 8 off the left side? Subtract 8 from the left side. Notice that positive 8 minus 8 is 0. So that's going to get rid of the 8 on the left. And that's equal to 14 minus 8. Okay, so we're going to put negative 8 on both sides. Notice that we've got the negative 8 on the left and the negative 8 on the right. So we essentially haven't changed our equation because we did the same thing to both sides. So now we have 2x equals, what's 14 minus 8? It's 6. Our x still has a coefficient of 2, and we need to get rid of that as well. So in order to get the 2 from the left side to the right side, we'll divide both sides by 2. Okay, we often express division as a fraction. So 2 divided by 2, or 2 over 2, is equal to 1. That leaves our x with a coefficient of 1. So we just have x on the left, is equal to 6 divided by 2, which gives us 3. Now we have 3 on the right. So x is equal to 3. That's the answer to our unknown variable equation. Let's perform a learning check. We have the equation P1V1 equals P2V2. This is actually a gas law equation. Pressure times volume equals pressure times volume. So pressure times volume at one situation under one set of conditions is equal to pressure times volume under the second set of conditions. And we'll explore these further in our chapter on gas laws. Let's solve this equation for P1. Solving this equation for P1 gives us first we need to get the volume from the left to the right. And remember, everything we do to one side, we have to do to the other side. So to get volume from the left to the right, we're going to divide both sides by V1. Okay, so now we can see that V1 divided by V1, and remember we express division often as a fraction. V1 divided by V1 is just 1. So we can leave it off because P1 times 1 just gives us P1. And that's equal to P2 times V2 over V1. Now realize that V2 and V1 are not the same, and therefore we need to keep both of those in. So P1 is equal to P2 times V2 divided by V1. Next, we'll consider interpreting graphs. A graph represents the relationship between two variables, and in this case, what we're talking about is a line graph that has two axes, so a two-dimensional line graph, where we have the x-axis horizontally and the y-axis vertically. So it contains two perpendicular axes. The horizontal or x-axis is this way, and it increases to the right, and the vertical or y-axis is this way, and it increases up. So in the next example, we'll observe a graph where the volume of a gaseous balloon and volume against its temperature, and we'll see the relationship between volume and temperature. You'll also remember that the x-axis represents the temperature, a linear equation, and the y-axis represents the volume x plus the x-axis is called our independent variable y-intercept, because we can change it, and it doesn't depend on y. That's the thing we're changing. And then the y-axis represents the dependent variable, that's x the volume. And y it's going to change x when and we y change coordinates at each temperature. Point. So, for example, the title indicates if x the volume is 20, of the balloon y is 24. Was measured at different temperatures. If x and the points represent the volume of gas in liters that 80, was measured at a specific temperature. Y is about and 29. Here we see the graph. We observe a direct relationship, a direct linear relationship between temperature and volume. We see that as we increase the temperature, volume increases. So as we go from, this is in C here, as we increase from 20 to 50 to 100 degrees C, the volume increases from 24 to around, let's say, 26.5 liters to around 30 liters.